Okay, we're going to do 4.2 trigonometric ratios and special angles. So by the end of today's lesson, you should be able to determine approximate and exact trig ratios for angles that are expressed not in degree measure, but in radian measure. You should also be able to solve some real-life problems involving angles that are expressed in radian measure. Okay, so to start off, if we want to determine some ratios for angles that are in radian measure, then we need to adjust our calculator so that the display is in radians and not in degrees. So check on your calculator for either a mode button or a degree button, something that allows you to just change the display from degree to radian. So it should probably say have either like a little D up there now and you want it to have a little R up there in the display, or it might say deg and you want to change it to rad. Careful, there's a grad, G-R-A-D, that's not the same. Okay, so sine of pi by 6, I know that pi by 6 is, well, pi is 180 degrees, and 180 degrees divided by 6, that's 30 degrees. Now, I don't encourage you to switch into degree mode at all, but I'm just, for starters, getting you to see that pi by 6 is the same as 30 degrees. But now, because it's in radian mode, we want to put that into our calculator using just our pi button as per usual. So just press pi divided by 6 equals, and then take the sign of that, and you should be getting 0.5. I'm just going to lock this because it looked like it was in danger of moving. Okay, so this is going to give me, don't know why, there we go, it's going to give me 0.5 is what you should have gotten. Why is it not? There we go. That's exactly 0.5. Okay, the cos of pi by 4, let's not even think about it in terms of degrees, let's just put in pi by 4 into our calculators and find the cos of that, and I'm getting 0.707. Now, the tan of 2 pi by 3, if I put 2 pi in, be careful, sometimes it doesn't let you put in 2 pi, you have to put 2 times pi, so you'll get to know your calculator. Divided by 3, so 2 pi over 3, that's about 2.09 radians, and that's going to be more than 90 degrees. And so, oopsie, I took the sign of it, oopsie. 2 times pi equals divided by 3 equals, and then I want the tan of that. That's giving me negative, approximately, and oops, I forgot my approximate sign there, negative 1.732 as my ratio. And does it make sense that this is negative? Well, we just discussed that this is about 2 radians, and 2 radians, remember we talked about that 60-degree rule there? So 1 radian was about 60 degrees, so 2 radians is about 120. So we know that 2 pi by 3 is over here, and that's in quadrant 2, obviously. CAS, only sign is positive over in that quadrant, and so we're expecting that the ratio for tan is negative there, so all good. Now you might notice that cosecant of pi by 6 is the reciprocal of the sine of pi by 6. Cosecant and sine are reciprocal ratios, and so I'm just going to take the reciprocal of 1/2, which of course is 2. Sec of pi by 4, well, that is the reciprocal of the cosine of pi by 4, so again I'm just going to use my reciprocal button on my calculator this time, and I get that the sec of pi by 4 is approximately 1.414. And the cotan is the reciprocal of the tan, and so in this case I'm expecting it to stay negative, but I've got 1.732 inverse, or sorry, reciprocal, so that's negative 0.577 approximately. Okay, easy peasy. So now we're going to get into our special triangles. So this down here says recall. Well, we've never expressed our special triangle in terms of radians, but it's, no, I should be trying to get that. What? that's not being very cooperative. Okay. I wanted it to look more like a 45-45 triangle. It doesn't, but you're just going to use your imaginations because I know you can. All right, so here I go. If I'm putting in, this would have been 45 and 45 and 1, 1, and root 2. That's the oldie. This is the new one, pi by 4. So same thing. We're just expressing 45 degrees in terms of radians. Remember, 180 divided by 4 is 45. So this pi by 4 is 45 degrees. Okay, so let's go and put some values in to our circle here. Remember, we talked in our prerequisite skills about the idea that at these certain points, like right here, we've got on our unit circle, this would be the point 1, 0. This is a point that we're going to talk about. This is the point 0, 1. We'll do these easy ones. This is negative 1, 0. Down at the bottom here, we have got 0, negative 1. Okay, and each of these, the first coordinate represents cos theta, the second coordinate represents sine of theta. So theta being the angle. Here the angle is 0, so the sine of 0 is 0 and the cos of 0 is 1. Now we've rotated pi by 4 radians, and so now this is like having this right triangle here. And I've got a special triangle then. Sorry, my stylus is not being very cooperative. So this is 1, 1 root 2. And I know that the sine of this would be 1 over root 2. And the cos of it would be the same, 1 over root 2. Now when I rationalize the denominator, it would be root 2 over 2. Let me just do that in the margin over here. So 1 over root 2. When I rationalize that, what I'm doing is multiplying it by the 1 equivalent of whatever the radical is in the bottom. So this is just 1, and so I have created this perfect square here, and so this is going to be 1 times root 2, which is root 2, over the square root of 4, which of course is just 2. Okay. So that's the cos of theta, sine theta. Over here, we've got the same thing. This is the same reference angle here, right? So these are going to be the same ratios. It's just that we're going to have some negatives here. What's negative over here? Well, sine is positive, so everything else is negative. So this is going to be negative root 2 over 2 and root 2 over 2 because sine is positive. If I go down here, the only thing, CAST, the only thing is tan is positive. That means that both of the ratios here are negative. And over on this one, same thing, except cos is only positive, so root 2 over 2 and negative root 2 over 2. Okay? So that's for this one. And then if I had the cos of 2 pi, that's 1. The sine of 2 pi is 0. Okay? Sorry, my husband's going to grab that. Okay, so this is going to be a really helpful tool then if I want to get the exact value for any of these angles here that we have discussed. So let's see what we can do with this. Okay, so we're going to try to find the exact ratio for the sine of 7 pi by 4. So the first thing you're going to do is you're going to draw the angle 7 pi by 4 in the Cartesian plane. I don't know what's wrong with this thing, and I'm frustrated. Okay. 7 pi by 4 is basically just, we're going to take pi and we're going to break it into 4s. So this is pi. Over here, 180 degrees is pi. So we're going to break it into 4. So we'll break the first half into 2 and the second half into 2. We've got 4 equal parts. Each one then is going to be pi by 4. Well, I need 7 of these pi by 4, so I've got 1 pi by 4, 2, 3, 4. I got to keep going if I want to draw that angle. So there's a couple more. So if I count and I'm drawing this angle, it's going to be, this is 4 pi by 4, better known as pi, 5, 6, 7 pi by 4. That is theta equals 7 pi by 4, but you know that you get your ratio from the reference angle. So this is pi by 4, and I'll just extend that. There we go. So we're going to draw our special triangle with 1, 1, and root 2 because this is the pi by 4 special triangle. This is going to be -1 because I'm in the Cartesian plane and I've gone down. Okay, so what is the sine of this reference angle? It's going to be opposite over hypotenuse, which in this case is going to be -1 over the square root of 2. Now, we don't leave a radical in the bottom. We engage in this process called rationalizing the denominator. So if there's a radical down there, we're going to multiply by the radical equivalent of 1. And in this case, we're going to use root 2 because that's what's at the bottom. So root 2 over root 2 is 1. And when I multiply the tops by the tops, that's the square root, negative the square root of 2. And then this is the square root of 4, which is better known as 2. Okay? So that's called rationalizing the denominator. All right, the sec of 4. So I'm just going to draw my Cartesian plane. I'm going to draw pi by 4, which I know is halfway between 0 and pi by 2. So this is pi by 4 right here, this little angle. I'm going to drop that perpendicular down to draw my triangle. So this is the angle pi by 4 right here. And I know that across from that is 1, this is 1, and this is root 2. So now, secant is related to cosine. So the cosine of pi by 4 would be adjacent over hypotenuse, but we have the reciprocal ratio, which means it's going to be hypotenuse over adjacent. Okay, so the secant of pi by 4 is root 2 over 1, which is just root 2. Okay, I want you to pause the video and try doing the tan of 5 pi by 4 by yourself. Draw the angle 5 pi by 4 in the Cartesian plane and then find the reference angle and figure out what the ratio is. Okay, so let's do it. 5 pi by 4, 1, 2 pi by 4s, 3, 4 pi by 4s. I'm going one more than 4 pi by 4 to get to 5 pi by 4. So that is this angle right here, which is theta equals 5 pi by 4. I'll just write in pi by 4 here, and I know that that's going to be 1. Sorry, that's -1. This is -1, and this is root 2. We always, on the hypotenuse or the radius, we always have a positive number. So the tan of 5 pi by 4 is just going to be, stick your finger on the angle, opposite over adjacent is going to be 1. Take a second to ask yourself, does that make sense? The tan is positive down in that quadrant, C-A-S-T. Sure does. Okay, so that is the special triangle pi by 4. Now we've got this other special triangle that you are familiar with, the 30-60, better known in radian terms as pi by 3 and pi by 6. So pi by 3 is just 180 divided by 3, which is 60. Pi by 6 is 180 divided by 6, which is 30. So you know across from the smaller angle is the smaller side length. So this is going to be 1. This is where the root 3 is going to go across from the pi by 3. And of course the 2 in the hypotenuse. Okay, so again, we can very quickly just generate all of these ratios. Let's see. Of course, this is 1, 0. We know that. Pi by 6, we'll just do the first one with the triangle here. Pi by 6, then, this is pi by 6. which means across from it is positive 1. Across from pi by 3 is root 3, and in the hypotenuse is 2. So if I wanted to do the cos, which is first, it's going to be root 3 over 2, adjacent over hypotenuse. If I wanted to do the sine, it's a half. I go to pi by 3, my reference angle then is pi by 3 here, which means if I did do a triangle, whoa, that would be across from pi by 3 would be root 3 over 2, and across from pi by 3 would be root 3 over 2, which doesn't make sense. Cos of theta is root 3. Just a second, I'm just thinking here. So this would be root 3, and the cos would be 1. Sorry, got that wrong. Just back her up. So this would be, let's just use a better visual here. If we've got pi by 3 and we want to do the cos of pi by 3, then it's going to be 1 over 2. Okay, so this is a half. Goodness. So this is a half, and the opposite over the hypotenuse would be root 3 over 2. Better? Okay, so now we just use symmetry. These are symmetrical, right? This one and this one. So I could put in root 3 over 2 and a half here. Same ratio, but one of them's positive. We know that sine is positive only in this quadrant, which means that cosine has to be negative. When I look at this one, this is also going to be 1/2. It's the same as this one because these are symmetrical. The reference angle is pi by 3. So I would have 1/2 and root 3 over 2, but of course it would be negative a half because cos is negative in that quadrant. Let's keep going. This is negative 1, 0. We're going to use symmetry again. These ratios are going to be the same for this one because our reference angle is pi by 6 here. So this is going to be negative root 3 over 2 and negative 1/2 because tan is the only one positive in this quadrant, so cos and sine are both negative. Keep her going. Right here, this one is the same as the one at the top you can't see, but you've got it written down. It's 1/2 and root 3 over 2, both of which are negative. We get over here, this is the same as this one. Cos is positive though in this quadrant, so this one's positive and this one is negative root 3 over 2. Last but not least, this one, cos is positive, so this is root 3 over 2, and sine is negative, so this is negative 1/2. Okay, I generated that all using symmetry, but I was able to figure out the first ones using my triangles. My triangle. Okay, let's try a couple of practice ones then. Let me just erase all that. Okay, so determine the following exact trig ratios. The sine of pi by 6, so we'll go ahead and draw it. Pi by 6, easy. Pi by 6 is 6 of these, and that would mean that we need to break each of the halves into 3. So this is pi by 6 here. It's hard to draw it, it's so small. So that's pi by 6. Sorry, I can't tell. Across from pi by 6 is 1. Adjacent to pi by 6 is root 3, and the hypotenuse is 2. So the sine of pi by 6, opposite over hypotenuse, that's just a half. The tan of 2 pi by 3. So again, I'm going to draw 2 pi by 3 here. 1 pi by 3, if I'm breaking pi into thirds, then I'm going to be kind of up like this. So this is 1/3, 2/3, 3/3. I get all the way to pi, right? So if I want the tan of 2/3, I'm going 1/3, 2/3. So this is theta equals 2 pi by 3. That means my reference angle is going to be another pi by 3, one more pi by 3. So 2 pi by 3 plus pi by 3 gets me to 3 pi by 3, which is pi. Does that make sense? So now I am going to put in my side length. So across from pi by 3, that's the longer side, that's root 3. Adjacent would be 1 because this is pi by 6, so across from pi by 6 is 1, but this is really negative 1 in the Cartesian plane, and this is 2. Okay, so we want the tan of 2 pi by 3. Well, the tan is opposite over adjacent, so I'm going to say this is going to be negative root 3. Root 3 over negative 1, which is negative root 3. Does it make sense that tan is negative in quadrant 2? Yes, it does. Okay, pause the video and try drawing 11 pi by 6 first of all, and then find the cosecant of that. Okay, let's draw this one out. 11 pi by 6s, yikes. So if I were to bother, I would divide each of these quadrants into 3 parts, but just you know that 11 pi by 6 is 1 pi by 6 short of 12 pi by 6. And 12 pi by 6, 12 divided by 6 is the same as 2 pi. So really what I'm doing is I'm drawing an angle that terminates somewhere here such that I only have pi by 6 left. Okay? So there, I've got pi by 6 here. Across from pi by 6, I got negative 1. Adjacent to pi by 6, I've got root 3. And I've got 2 on my hypotenuse. Okay, so this is theta equals 11 pi by 6. Okay, cosecant is related to sine. Stick my finger on here. The sine is opposite over hypotenuse. And if I take the reciprocal of that, it's hypotenuse 2 over opposite, which is negative 1, which is just negative 2. Okay? Did you get that? I hope so. All right, do you want to pause it again and try another? Cotan of 5 pi by 3. Okay, whoops. So there's my Cartesian plane. Pi by 3, there's 1 pi by 3. That's 2 pi by 3s there. So 1, 2, 3 pi by 3s. 4, 5 pi by 3s. I'm getting all the way to the 4th quadrant. What do I have left before I hit 2 pi? I've got 1 pi by 3 left, right? Because 1 pi by 3 plus 5 pi by 3 gives me 6 pi by 3. So this is theta equals 5 pi by 3. I've got my pi by 3 here. I'm going to draw my triangle. Across from pi by 3 is root 3. And in this case it's negative because we're down in the bottom here below the x-axis. This is positive 1 and this is 2. And so the cotan, well, cotan is the same, is related to tan. Tan is opposite over adjacent, so we're going to have it the other way. We're going to take the reciprocal, so it's going to be adjacent over opposite. And I need to rationalize the denominator here, so I'm going to say the cotan of 5 pi by 3 is equal to 1 times, you can put the negative 1 in the top, root 3 times root 3 over root 3. Just put the negative in the top just so you're not thinking about including it here. Okay, so this is going to be negative root 3 in the top. When I multiply the tops by the tops, and the bottom would become 3. Okay, so the cotan of 5 pi by 3 is negative root 3 over 3. Does it make sense that cotan and tan are negative in the 4th quadrant? Yes, it does. Okay, well, we haven't really gone into too much detail about this one today so far, but you know, if this is the Cartesian plane, these are the coordinates. And you also know that the angle of rotation here is 0 radians, right? We haven't rotated at all. So I could say that the cos of 0 radians is 1. And I could say that the sine of 0 radians is 1. Sorry, it's 0. Over here, the cos of pi by 2 is 0. And the sine of pi by 2 is 1, etc. Okay? I could also use the rule that tan theta equals sine theta over cos theta to find other ones. So I could ask you, what's the tan of pi by 2? And you would take these two ratios, and you could say the tan of pi by 2 is 1 over 0, which is undefined because of the division by 0. Okay? You can do cotan, you can do cosecant, etc. So if I asked you, for instance, the cosecant of pi, well, the cosecant of pi is related to the sine of pi, right? The sine of pi is 0, and if I take the reciprocal of 0, I get 0 on the bottom. So this is also undefined. Okay? And so there's a lot of exact values that come out of just simply drawing out the unit circle and putting those 4 coordinates in. Okay, so what we're going to do now is we're going to solve a problem. This is an exact question, literally, except the numbers have been changed from your textbook. So just get it down and follow it closely when you see that question in your textbook. So Sarah's flying a kite at the end of a 30-meter string. The sun is directly overhead and the string makes an angle of pi by 6 with the ground. Suddenly the wind speed increases and the kite flies higher until the string makes an angle of pi by 3 with the ground. So a couple things. The string doesn't get longer when the burst of wind happens, so it's still going to be 30 meters. The other thing is that if the sun is directly overhead, it's really telling you that there is a shadow that is formed because the sun's rays aren't penetrating through the string. So theoretically, along the ground, there's a teeny tiny, skinny little shadow. That's what they're talking about when they want the shadow, okay, the horizontal distance of the shadow. So let's see if we can draw this out. We've got this string, 30 meters. So there's the beginning of the kite there, and Sarah is just a little bug on the ground, okay? We're not considering her height or anything. We've got this shadow that forms along the ground, and if we drop a perpendicular there, then what we're saying is, I think it was also telling you that this angle that the string makes with the ground is pi by 6. So we're trying really to find the length of the shadow, right? The horizontal distance of the shadow when it's in position 1. So position 1 was before the gust of wind. Okay, so we're going to say let x represent the length of the shadow in position 1. And we're going to use meters. Okay, so there's a couple of ways you can do this. You can use similar triangles. So if I drew a similar triangle to this one, what if I had the same angles? Remember, similar triangles all have the same angles. So pi by 6 and 90, and pi by 3, obviously, if this is a 90 degree. I know that this is the special triangle, pi by 6, pi by 3, so I know across from pi by 3 is root 3. I know across from pi by 6 is 1, and I know the hypotenuse is 2. So these are similar triangles. So by similar triangles, I could say, I'll just write using similar triangles, we would have that these two are related, so we would write 30 over 2 equals, so this one is to this one as x is to root 3. So I've set up a proportion. I can cross multiply to solve. I'm going to divide both sides through by 2 here. And I'm going to get 15 root 3 as my length of my shadow. This is the exact value. Therefore, the shadow is 15 root 3 meters long. Okay? All right. The other way that we could do this, if we just refer back to the original diagram that I drew here, this one, you could just stick your finger on the angle and use trigonometry. So, using trig, stick your finger on here. We're trying to find x. We have this side. We're going to use the cosine ratio. So cos of the angle, pi by 6, is adjacent over hypotenuse, x over 30. And we know the cos of pi by 6. We can use the special triangle. So the cos of pi by 6 is root 3 over 2. So we're just going to replace that with root 3 over 2 equals x over 30. And we're going to cross multiply to solve for x. So this is 2x equals 30 root 3. X equals 15 root 3 meters. And we have the same conclusion. Okay, so you can use either approach and you're going to get the same answer. All right, let's keep going. Clear this off. Okay, determine an exact expression for the horizontal distance of the shadow when the kite is in position 2. Well, if we go back to our diagram here, position 2 said the gust of wind happened. So I'll just use a different color here. So this doesn't change its length, but it's going to change its position. So now it's here. It now forms an angle of pi by 3 with the ground, which means that the shadow is going to be quite a bit shorter. It's just going to be this distance here. Okay, you could call this, I don't know, do you want to call it y? So let's go and put that into this problem here. So we're going to say let y represent the length of the shadow in position 2 in meters. Okay. So again, I'll just use one method then. I'll use the second method we talked about. So I'll just transfer the diagram here. We have something like this. This is pi by 3. This is y. This is 30. Stick your finger on the angle. We're still going to use the cos of pi by 3. That's adjacent over hypotenuse. And we know that the cos of pi by 3 from our special triangle is going to be, let me just draw it here so everybody can see it. So this is pi by 3, which means this is root 3, this is 1, and this is 2. And so the cos of pi by 3 is a half, adjacent over hypotenuse, equals y over 30. Cross multiply, 2y equals 30, and y equals 15. Therefore, the shadow is exactly 15 meters in position 2. Okay. So far, so good. And now it says determine an exact expression for the horizontal distance that the shadow moves between the two positions of the kite. So what it's saying is, all right, we found x. This was this whole distance here. It moved. Now it's smaller. That's y. But how far did it move? Okay? And that's the difference between x and y. So we are going to say, I don't know. We could say let z represent the horizontal distance. The shadow moves. Just ignore that. In meters. So we're going to say z equals x minus y. And x was 15 root 3 and y was 15. And that's as simplified as you can get. Now, I don't know. I mean, to me, that's more simplified than factoring out the common factor of 15. We'll see what your textbook does, but to me, this is a nice solution. Therefore, the horizontal distance the shadow moves is 15 root 3 minus 15 meters. I know that's an awkward number, but that's the exact number. Determine the approximate distance. you can go ahead and do that. The approximate distance, you're just going to calculate the square root of 3. I don't have a calculator with me, so I'm sure you can figure that one out. Okay? All right. Thanks for listening. Good night.